Today we got a walk-in freezer that is not freezing. Our temperature is displaying 31 degrees. Temp control is calling. Let's see, our set point is -10. Fans running. Evaporator coils frozen over. Alright, let's go put the system into defrost and make sure the defrost cycle is working good. Here's the condensing unit. Okay, let's put it into defrost. The clock is not going into defrost. Why not? That run capacitor looks swollen. We'll have to check that. Well, yeah, the unit's not going into defrost. I wonder why. You know what we could do is, it's possible that our defrost termination is stuck, maybe. So we'll disconnect defrost termination here, X terminal. We'll see if it goes into defrost there, because it's possible that if the defrost termination is satisfying, it won't let the clock go into defrost. So let's disconnect this. This wire, defrost termination, was touching the N terminal. Let's see if it'll go into defrost now. Yep, just went into defrost. So it was a bad electrical connection. Alright. Let's power this unit down here and fix all this wiring. And we'll go make sure the evaporator is defrosted. Great. There's wasps in there. Not wasps, yellow jackets. Terrific. Alright, let's go get our spray and spray them to get rid of them. Okay, we get our spray, wasp and hornet. Let's give it a quick little shot here. Okay. Die. There's new stuff flying out. Break that off. So it's pumping now. I'm hoping that it's pumping now. Yep, it's pumped out. Good. Is there only two in there? I hope so. Pull this Okay. Let's go get our voltmeter. We're gonna test the capacitors, clean up the wires. Okay, let's test, make sure we got no power in here. Nothing on top, nothing on the bottom. Okay. Twist all these strands together so they're not sticking out. Okay, I'll go into X terminal. Let's loosen this up a little bit more. Securely. Okay. Now let's make sure all the other wires are secure and clean, not touching anything. Okay. For this orange one, see this straggler? Things like that, you can't have that. You gotta make sure they're straight, fully inserted, and tight. Much here. Let's cut this back 10. Okay, like that. That's it. Just gotta clean up. Let's test this capacitor. Remove these two wires. So we're looking for how much? About 30 microfarads. Switch that to microfarad. Don't tell me it's open. Yep, it's open. It's a bad run capacitor. Okay, we'll definitely have to replace that because that puts a strain on the compressor. It'll burn out the compressor run winding. So, this is the run capacitor. Let's test this start capacitor. And we're here looking for 145 to 175 microfarad. We are still counting 156 microfarad. So that is plenty within range. That's a good start capacitor. Okay. So we've got to replace this run cap. Alright, we can power this system back on, put it back into defrost, and go test all the evaporator heaters, make sure the defrost is working good. Puddle here. Dry this off. Okay, it's still in defrost. Yep. Let's go look at the evaporator. Actually, let's test. I mean, I'm sure it's good, but we can test to make sure that our defrost is in. We have power between N and number 3. So this is N. In 3, 242 volts. Okay, proper. Between N and 4 there should be nothing. Okay, wonder what they're running this F terminal, this brown wire. Interesting. Okay, let's go down and check it out. Okay, let's move some of this stuff out of our way. Let's take amp draw. Let's see, we'll take an amp draw on. We could do it on the heater wire. Let's see. Actually, we could just do it on N. N coming in, this is orange one, right? And we got 3.8 ohms. Now let's make sure each one of the heating elements is pulling amperage to make sure every heater is working. Alright, the very top heater is pulling 1.2. Bottom heater 1.2, and let's see, actually that was the middle one. This bottom coil bottom heater is pulling 0.6. That's a little different, but it could be a different watt element. And let's test this last. It's a pan heater. That one's reading 0.6. So those two heaters could be the same, but they are all pulling amperage. So that is good news. Also good news is the pan itself is clear. There's no plug in the drain. This should be good. So we will assist in de-icing this coil just to get it done faster, but I do want to confirm that our defrost termination is going to work properly. Let me visually look at it. And visually, so far it's covered in frost, but it does not look damaged, but we'll see once all this is melted. Usually it'll be pushed open and whatnot. I'm gonna grab, take off this cover and grab some hot water and de-ice this quicker. Let's go get the water. So I'm going to start de-icing from this side over to this side, because this is where the defrost termination is at, and I want the heaters to stay on as long as possible just to assist. Okay, all the ice is gone. Let's move on. Okay, so I got the whole coil defrosted, cleaned up. Last part is here. On this side, this is where the defrost termination switch is, and I want to see if this defrost termination switch is still good, because it was getting voltage improperly through the, it was getting powered from N terminal and back feeding through the X wire. So I'm gonna use hot water to try to warm up this defrost termination and see if it'll come out of defrost. If not, we may have to replace this defrost termination switch. Get rid of all this ice. built up. Yep, it just clicked out of defrost as soon as I put warm water on it. The defrost termination is working. Okay. Let's reassemble these panels and let it run. Oh, so what was they using this gray one? Oh, it's not running to anything. This brown wire that was connected at the defrost clock on the F terminal, they just got it capped off over here, so we could disconnect it up there. Doesn't need to be connected there. Yeah, because they got it right here disconnected. They terminated. Okay. Defrost clock is turned off. Liquid light solenoid valve is open. Coil is freezing. The fan is not on, which is proper operation. It's waiting for the coil to freeze, and then it should turn on the fans. So we'll wait for that. We know the fans do work, and when we got here the fan was running. I'm pretty sure the operation will be good. Okay, we got the new capacitor. Gonna pop that in. Okay, that's done. Alright, unit should be repaired. Customer also asked me to replace the door closer because it wasn't pulling the door closed all the way in on the cooler side. So we'll get that done. But the freezer is coming down in temp very slowly. It was at what, 30, 31, 32 when I got here. It's down to 27. So it's coming down but slowly. I think it's having a hard time coming down because this coil is so beat up. I want to see if I can't try to straighten this out, make it look better for better airflow. While this unit's staying in defrost, just want to test the defrost one more time. That's as good as I'm gonna get this oil straightened out. Alright, defrost cycle came out. Let's make sure, what is it, 412? Okay, it's about that time. How many defrost cycles is there? Let's see, 4 cycles. Noon, midnight, 6 a.m., 6 p.m. Sounds about right. Let's actually turn 2 more cycles on. We'll do 3 a.m., 3 p.m., 3 a.m. That's it. Let's go replace that door closer. We'll be good to go. Okay, good. Closes the door by itself all the way. The latch is engaged. Now at least the door is pulling in tight. Last thing is I need to find out what type of door gasket this is, and yeah, it's torn. I need to take the dimensions of the gasket, find out which type of a gasket, get this part number, and order it. happening there. How was it glued? Okay, so this gasket is like super glued in the corners and the ends, pain in the butt to remove and get a good profile of it. But now that I got a good profile, I can try to match this up. Okay, so it's not going to be any of these. See any of these? No. Not that one. Not that one. Not that one. So it's this one right here. Number 10516. Yeah. 10516. And now you just gotta record the gasket width. So we got 33. About half an inch from this track to the edge of the gas station gasket. So we do 33 7/8 minus almost 1 inch, so let's do 33 inches by 75. 33 by 75. That's a gasket size. And that's how we'll order the new gasket. 33 by 75. Okay. Cooling. Very slowly though. Should probably check refrigerant pressures just to make sure. Yeah, taking a long time to cool. Okay, looks like we're running 5 degrees subcool, 19 degrees superheat. Superheat's a little high. See if it drops down. Freezer superheat should be around 7 to 12, somewhere around there. The box is at 27 degrees. Our vapor saturation is 1 degree. I think that's a little low. Okay, so as our temperature drops, our superheat's also dropping, so we're gonna be okay. Alright, I'm gonna remove my probes and call it good. Repair complete.